Thank you all for coming. Our last lunch talk of the semester.
Sit here. Somebody sitting here, Mark?
Nope. We're gonna get started, please, ladies. All right. Thank you all for coming. And Dr. Astalos is going to talk about the eclipse that's coming up this summer.
Thank you. Yeah, bring them on down a little bit so they don't see me. Bring them down. There you go. Yeah, that's probably good. Yeah, that'll work. Thank you, everybody. It occurred to me a couple of months ago when I started asking students, do you know about the total solar eclipses coming up in August? That none of them did. They'd never heard of it. And I've been looking forward to this thing for years, and I'm just amazed that people don't know about it. How is that? So I said, okay, I guess I better do some talks and get the word out there. So before I go any further, I do want to... This is not the same. I don't know what's... Hold on, let's just take a second. I want to thank the people at the Space Telescope Science Institute in Maryland. Their Office of Public Outreach does public lectures every month at least. And back in January, they did one about the eclipse, and I shamelessly stole a whole bunch of slides from them because they're good. So thanks to Frank Summers and his group out in Maryland. So anyway, before we talk about the solar eclipse and solar eclipses in general, in order to understand eclipses, you need to first of all understand shadows. So shadows of celestial bodies, no matter what the body is, whether it's a planet or a moon or an asteroid, it's going to have three parts. Now the scale is really horrible just to give you an idea of the shadows. We're trying to emphasize the parts of the shadow here. If you're right behind the celestial body, all of the light from the sun will be blocked. You'll be in the darkest part of the shadow, that's called the umbra, and no part of the sun will be visible. If you wander out of the umbra this way, you're going to be in a place where part of the sun is visible, but part of it is blocked. And that area is called the penumbra. It's not the darkest, but, and I guess that comes from penultimate. It's the second darkest part of it. Now, it turns out that the umbra is cone-shaped, and it only comes so far back, and then you get into a different part of the shadow. If you're back here in the antumbra, then you can imagine part of the sun up here will be visible at the top, part of the sun will be visible just below this planet or moon, and if you can imagine to the left and the right as well, you'll see a ring of the sun. Now, what kind of eclipse you get depends on what part of the shadow you're in. So, here is another not-to-scale picture of the sun, the moon, and the earth creating a solar eclipse. And so if you're in this situation where the umbra reaches all the way to the surface of the earth, then as long as you are in the umbra, as long as you're on the part of the earth the umbra is going to pass by, you'll get a total solar eclipse. The entire sun will be blocked out. The sun's corona, the very hot outer part of its atmosphere, will become visible. Stars will come out. It'll cool down. Lots of interesting things happen. And I'm saying this because other people say it. I've never seen one. I'm very excited about August because it'll be my first. Now, if you're out here in the part of the earth where the penumbra goes past you, you don't get the entire sun blocked. You get what's called a partial eclipse. So it'll look something like this through these glasses. These are for you guys to take as well and have this summer. I've also got information sheets from NASA about the eclipse. You can help yourself to those as well. Now, it turns out the moon's orbit around the earth is not a perfect circle, it's an ellipse, which means that the moon is further from the earth at some times and closer to the earth at other times. And being the way it turns out, the umbra is not that long. It's long enough that when the moon is close to earth, the umbra reaches the surface, but it's not so long that when the moon is further from the earth, you still get total eclipses. So when the moon is further from the earth, the umbra ends, and then you get the antumbra. And that antumbra, as the moon goes around the earth, carves out a path along the surface, and if you're in that antumbra when the shadow goes by, you see what's called an annular eclipse. you get a ring of sunlight. And that word annular comes from the mathematical term for a ring, which is annulus. That's where that comes from. Back in 2012, there was an annular solar eclipse that passed right through Albuquerque. And I know quite a few people from here went down to Albuquerque for that. And I've actually got some pictures that I took there in just a little bit. So those are the different types. There is actually one more type you might see when we look at the NASA webpage, and that's called a hybrid. It's possible under just the right conditions that an eclipse may start out annular and then become total and then become annular again in the course of passing along the Earth, because the Earth's curved. And so when the shadow is out here, it's got to go further before it hits the surface. That's sort of the typical hybrid. There can also be hybrids where it starts total and goes annular, or where it starts annular and becomes total. So when you look at this picture, you think, okay, the moon has to pass between the Earth and the sun, and well, the moon goes around the Earth, so why don't we see an eclipse every single month? Turns out that the plane of the moon's orbit is not parallel to the plane of the Earth's orbit. So in this picture, they've got a model. They're using the surface of the water to represent the plane of the Earth's orbit, called the ecliptic. And they're making very clear here that the moon's orbit is actually tilted a little bit, 5 degrees roughly, to the Earth's orbit, to the ecliptic. And so, most of the time, the moon is either below the plane of the Earth's orbit or above the plane of the Earth's orbit. It does pass through the Earth's orbit twice every moon orbit. So once going from south to north, that's called the ascending node, and then on the other side going from north down to south, that's called the descending node, and a line connecting them is called the line of nodes, and that's going to be important in just a minute. What that means is, so this is to scale. They've got the shadows and the sizes of the Earth and moon to scale here. That means most of the time when the moon is between the Earth and the sun, they're assuming the sun's out here somewhere, the moon's shadow passes above the Earth. If the new moon happens when the moon is down here, it'll pass below the Earth. So the moon's shadow, 4 times out of 6, will pass either above or below the Earth. You will not get an eclipse. And during full moon, if the moon goes through the Earth's shadow, you'll get a lunar eclipse. But again, 4 times out of 6, roughly, the moon will pass either above or below the Earth's shadow, and you don't get a lunar eclipse. Whoops. In order for the eclipses to happen, that line of nodes has to line up with the sun. Then the moon will be passing through the plane of the Earth's orbit at the time it's either new or full, and you have a chance for the shadow of the moon to fall on the Earth and create a solar eclipse. And this picture makes it look like, okay, that happens about once every 6 months, right? It happens here, and then 6 months later, it's over here. So this thing we call an eclipse season happens about once every 6 months. Now, it's not exactly once every 6 months, because the moon's orbit is much more interesting than just constantly going around and around. It turns out that line of nodes precesses. So as the moon orbits around the Earth in this direction, those nodes actually turn the opposite way very slowly. And so the eclipse seasons actually happen a little bit less than 6 months apart. In this picture, we've got the months, January through December, across horizontally, and we've got the years, 1990 to 2000 to 2010. And what they're plotting out is the eclipse seasons. So you notice there was an eclipse season right at the end of July 1990, and to get another eclipse season at that time, you got to come down to 2000. That's when the line of nodes has gone around 180 degrees. To do a full 360, you have to go a little further down here. So those eclipse seasons happen a little bit less than 6 months apart. When you combine that precession of the line of nodes with the 29.5-day lunar cycle, new moon to new moon, and the 27.5-day anomalistic month, that is from perigee to perigee. Perigee is the closest approach that the moon makes to the Earth. So every orbit, it gets as close to the Earth as it's going to get at perigee. On the other side, it's as far away as it's going to get. And then it's back to perigee 2 weeks later. So a 4-week orbit, basically. And that changes a lot, too. The distances between the moon and the Earth oscillates, so perigee distance gets bigger and smaller. But it also precesses if you can imagine taking all these lengths of time and trying to find the least common multiple, it turns out to be about 18 years, 11 and 1/3 days. It's 6,500, something like that, days, but it comes out to 18 years, 11 and a third days. And what that means is if there is an eclipse on one particular day, like last year, there was a total solar eclipse on March 9th here. 18 years, 11 and a third days later, there's another one. Let's just say 18 years, 11 days, and that would be the 2034 on March 20th. So 11 days later, 18 years. That 1/3 of a day means that the Earth has rotated about 120 degrees from where it was during the last eclipse, which means that the eclipse that happened back in 2016 is here, but the one 18 years later is here. And so you'll see in one cycle of these eclipses, the Saros cycle, the eclipses that occur in a Saros will move from east towards west, each one after another, 18 years, 11 and a third days apart. This is a picture from a textbook just highlighting a pair of eclipses from lots of different Saros series. So the red ones are connected. They're part of one Saros. These orange ones are connected. So 2017, that's this year's eclipse. Go 120 degrees around. 2035, there'll be another one, and so on. So they're just showing individual pairs, which is good to get an idea of how consecutive eclipses in a Saros series relate to each other. But to get an idea of one Saros series, it's kind of great to look at a picture like this. All of these eclipses are from Saros 136. So the first one that's plotted was back in 1901. The very first one would have been much further down and probably a couple hundred years earlier than that. But the first one graphed here, this is the path of totality. And it occurred in 1901. 18 years later, 1919, May 29th, 11 days. The third of a day means it's moved over to the west, about 120 degrees. Then 1937, 1955. Notice that they don't just move from east to west, 120 degrees, they also move up a little bit. What's happening is that point where the moon passes between the Earth and the sun, 18 years, 11 and a third days, it's actually moving up each time, a little higher and higher. And so the Saros series starts when the moon is its shadow is just hitting the south pole of the Earth. 18 years later, you get another one, it's a little further north, and so on. And this Saros series will continue for 1,300 years-ish until the moon shadow for this series passes by the North Pole and they're gone, and this Saros will be over. And notice, eventually we get to this one. We'll be talking about this one. This particular one in 2045, the path of totality will pass between Alamosa and Denver. Yeah, and that is going to be, here in Colorado, that's going to be better than 5 minutes, longer than 5 minutes of totality. I am taking my vitamins and exercising. I'll be 83 and I'm going to be here for that one right there. Think positive, right? So this is kind of a cool way to start to get a feel for it. But remember, the Earth is a sphere. So here's a different look at a different Saros. This is Saros 145, so it's a different series of eclipses. And the very first one here, you can see right up by the North Pole, 1891. 18 years later, 1909, so there's the path of that eclipse. 18 years later, the 1927 eclipse. 18 years later, 1945, and so on. And again, they're moving southward, and they're all about 120 degrees in longitude west of the previous one. And if you follow them all the way around, you get to this one, the one that's coming this year, passing right through the continental United States. I will get into more detail about this particular eclipse, but I'm going to talk about eclipses in general and how to find out about these eclipses and what eclipses are coming in the future before. Okay? Now, I found this animation of these eclipses in a given Saros cycle. So NASA put together, or someone related to NASA put together a series of pictures like this for every eclipse in one Saros series. And the pictures look like this. I want to give you a little introduction because when they animate them, it gets a little crazy and you may feel ill. Just close your eyes. But the pictures look like this. They've got the pictures set up so that the eclipse is visible. They rotate the Earth however they have to. So when we run the animation, you'll see the Earth is just going nuts. But this is a picture that tells us what's going on with the eclipse. The blue line is the path of totality. So out here, you've got partial eclipse. Over here, you've got where the eclipse ends, where the moon shadow passes off the side of the Earth or joins with the Earth here. The star right in the middle shows you the point of greatest eclipse. And then this X marks the subsolar point. That is, if you drew a line from the center of the sun to the center of the Earth. So that's where it would go through the surface. So you can see that the moon's shadow is actually passing north of the Earth-Sun line here. Okay. The path being blue is what tells you it's a total eclipse. If it's an annular eclipse, it will be red. So when we run this animation, watch. We're going to start down here at the South Pole, and the eclipses will work their way north. And you will see, first of all, an annular eclipse. It'll be a red line. And then you'll see some blue come in the middle and push the red out to the sides. Each frame, remember, is one eclipse. It's just running them all together. Are you ready? If this bothers you, just close your eyes. So there's Antarctica. There you go. You see it was a red line. Now it's blue. Got real thick. So the moon was closer to the Earth. Disappears off the north end. And you could see the red. You guys see the red at the beginning? It started out as multiple annular eclipses. And then there was hybrid while the total part was pushing the annular part out. But it disappears off the top. And notice it went from around the 1300s to around 2500, I think, for this one. Yeah. So 12, 13, 1400 years is what it takes for one Saros cycle, one Saros series to live itself out. I'll show you one more. It's going to start at the North Pole and work its way down. And this one, let's see, this was Saros 136. And then this next one is Saros 145. Starts at the North Pole, works its way down. Interestingly, they're all partial. From the beginning on, they're all partial until you get to one annular and then right into totality. So you probably saw a flash of red, and then it was blue. They're all different, depending on the exact geometry of the moon and its orbit around the sun. So it's kind of cool to see how the eclipses in a given Saros work their way across the Earth. At any given time, there are multiple Saroses going on. And when I show you a list of eclipses over the next 10 years, you will see lots of different Saros numbers. So enough of that. Let's get away from that. If you go to NASA's website, their Eclipse website, you can find lots of data on eclipses over a period of about 5,000 years. This is one that I borrowed from the Space Telescope Science Institute. It's just some data on the eclipses all over the world during the 20th century. Total, there were 228 solar eclipses, counting all different types. There were 78 partial, 73 annular, and 71 total, which honestly is a little surprising to me. I would have thought there were a lot more partial, but that's the way the numbers work out. There were 6 hybrid. Among the 20th century eclipses, the longest totality was 7 minutes, 8 seconds, meaning if you were there at the greatest duration point for that eclipse, the sun would disappear and be gone for 7 minutes, 8 seconds before it started to peek back out behind the moon. This year's eclipse is going to be, if you go to Wyoming, Nebraska, it's going to be around 2.5 minutes of totality. There's going to be longer ones coming up in the next couple decades. For records, there were 5 solar eclipses during 1935. There was no other year in the 20th century where there were more eclipses in one year. And we actually had 1 month where there were 2 solar eclipses. They were both partial, and one was on July 1st and the other was on July 31st. When I saw that, I just had to go look them up and see what we were dealing with. But okay, so now it's time to take a look at NASA's Eclipse website. And you do not need to know the website address. Just Google NASA Eclipse, and it'll take you right there. That's what I always do, because I'm lazy. So let's see. It always gives me the error. It's going to work, don't worry. There it is. And of course, you guys can't see it, so let's see if I can. Yay! All right. The great thing about a wireless mouse. Okay, so you come to this website, and the very top thing here, they have this huge page just for this year's eclipse. And if you want to go see all kinds of stuff for this year's eclipse, go for it. For teachers and other group leaders, that might be a good place to get resources and things. But if you want to just explore other eclipses, again, this is this year's eclipse. If you want to explore other eclipses, this is the place to come to. So, right here, eclipses of the sun, these are links to lots of different lists of eclipses. If you want to start by looking at a big picture all around the world, where are these eclipses happening? Go to the World Atlas of Solar Eclipse Maps. So let's look at right now, 2001 to 2020. You get a 20-year picture of all the eclipses that are happening around the world. And the red ones are the red ones are annular and the blue ones are total. And I set my, there it is, my laser down. So here's the 2012 annular eclipse that went through Albuquerque. Here's this year's total solar eclipse going through the US. But if you're traveling around the world at any time, you can go and look and see when are there going to be eclipses in those places. You can also pick out a few Saros Cycle relatives on here, but because it's only a 20-year span, there's only a couple. Marty?
Is the width of the line there proportional to the...
Yes. Yeah, so it's the width of the line indicates the width of totality or annularity. You notice up around the poles, they get really big, and that's just because we're taking a sphere and flattening that skin out into a big flat. That's distortion due to the projection. But yeah, the thicker ones, you have a much wider path of totality or annularity, and the thin ones are very small. In fact, when you get thin ones like this, you notice the red tips? That's a hybrid. And it actually ends total. So you'll see a couple. Here's another hybrid that starts annular, becomes total, and then ends annular again.
So that's based on the distance that the moon is from the Earth?
Yes. Yep, exactly. So you can look, if we go back. So you can look at all these different centuries. If the maps here don't match the time period you want, if you're a historian, you want to go back further, you can actually go down here to the 5 millennium catalog of solar eclipses. Go back to 2000 BC. So if you want to look at the eclipse that interrupted the Battle of Hammurabi, I'm not a historian, you can go look them up and find out the circumstances of that eclipse, where it went, how long it was, things like that. Now, the cool stuff, though, once you've figured out where the eclipse is that you want to visit, oh, let me show you one more. If you're just interested in North America, this will give you 50 years at a time. So if we go to 1901 to 1950, so here's a map of all of this is just total solar eclipses, all the total solar eclipses that touched North America in the time period 1901 to 1950. And there's a lot of them here. There's only one that actually crossed the continental United States from Pacific to Atlantic. That happened in 1918. That's the last time that happened. So that's why people are saying this is going to be the greatest eclipse in almost 100 years. They're saying this is the first time in almost 100 years that a total solar eclipse crossed the continental US from Pacific to Atlantic. Now there are others, look at this one, from the Pacific, across Central America, out to the Atlantic. What's wrong with that? To say it's the greatest eclipse in 100 years is very North American centric, but anyway, so you can see where they're at, where those eclipses occur. If we look at the next period, let's see, total 51 to 2000, you notice there are none that cross from Pacific to Atlantic. And in fact, this one right here, 1979, that's the last time any total solar eclipse touched the continental US. So it's been almost 40 years since the continental US has had a total solar eclipse. That's another reason it's really cool to be able to go do this. And if you are interested also in annular eclipses, you can go down here to the annular eclipses, and if we look at this one, you'll see one really skinny one right there, passed right through Atlanta, Georgia, right across the Georgia Tech campus, right on top of the building that one particular undergraduate physics major was working in. We hung out on the roof and enjoyed that annular eclipse. That was my first ever. What's that? That was 1984, May 30th of 1984, yeah. Okay. So there's ways to go to this. Yeah, I know. My wife's reminding me how old I am. This is a great way to go and find out when there are going to be eclipses. Now, once you know what eclipse you want to look for and find out its circumstances, come up here to the decade solar eclipse tables. You can go to some of the other places like solar eclipses on Google Maps, but they don't tell you where the eclipse is visible. So this has a little more interesting and useful information. So let's look at, I don't want to get to this year's yet, so we're going to look at next decade, 2021 to 2030. And down here is a list of eclipses. And let's see, there we go. So here's the date. TD is, that's essentially Greenwich Mean Time. That's dynamical time is what it stands for. The eclipse type, annular, total, partial, or hybrid. Then here's the Saros series that it's a part of. You see lots of different numbers. And then over here, graphic region of eclipse visibility. So up here, it tells you where it's going to be visible, but that's anything. That's any part, partial even. So looking there doesn't really help. If you want to find an eclipse that's going to be visible where you are, you need to look at the bold. So this is where it's annular. This is where it's total, and so on. 2024, let's see. 2023, this is the annular eclipse. Albuquerque is going to get another annular eclipse in 2023. Not fair. Turns out there's a city that in Illinois, I think, that is going to get 2 total solar eclipses within 7 years of each other. Yeah, that's not quite enough to make me want to move there, but it's interesting. So this one here, North America, it's total in Mexico, central US, and eastern Canada. If you click on the date, you get a map that's full of all kinds of good information, but most people don't care that much about. If you click on the time, you get a very cute little animation that shows the moon's shadow crossing the Earth for this particular eclipse. And you can see that it speeds up along the edges because the Earth's surface is moving away, but the moon continues linearly at roughly the same speed. So that's cute. The really cool thing happens if you click on total. Now you get a Google map that, let's get it right in the middle. There we go. The first thing you want to do is click large map, get it as big as possible. Now you can interact. You can roll the mouse button and zoom in. And you'll be able to zoom pretty far in. Greatest eclipse and greatest duration. Greatest eclipse is where the line of totality, central totality, comes closest to the line connecting the sun to the center of the Earth. Then greatest duration is the place where it lasts the longest. There's not much difference. So the duration is up here, duration of totality, 4 minutes, 28 seconds. At greatest duration, it's 28.1 seconds. So, and it doesn't change that quickly. If we go into, say, Texas, because we're up here, right? There's the San Luis Valley. Closest for us might be somewhere in here. So if we travel in 2024 to there, we're getting 4 minutes, 18 seconds. So it's not that big of a difference. But it tells you how long totality is, the times. Again, UT, that's basically Greenwich Mean Time. You guys know how to convert from Greenwich Mean Time to your local time? What's that? What are we in now? It's not add. Yeah. We are currently in Mountain Daylight Time, which is 6 hours behind Greenwich Mean Time. When we're not on daylight time, so what, November, December, January, February, then we are 7 hours behind, so you have to subtract 7. Of course, if you go here, you'll be in Central Time. You'll have to, what is this? What's the date here? What's the April? So it's, here you'll have to subtract 4. 5? 5. Yeah, so you got to keep track of that to convert. But this will tell you when the eclipse is going to happen at this location. And start of total to end of total is what should be this duration right here. Okay? If you want to check the place out and go, hey, where should I go? Let's zoom in. Hey, maybe I'll go over here, and I don't like Texas. I'm going to go to Oklahoma.
I don't recommend it.
Sorry, nothing personal, Ashley. Didn't mean that. You can switch to satellite and actually see roads. You will run into this error message when you zoom in too far. It's telling you that they've restricted the level of zooming because of the finite resolution of the data, the eclipse path data. But it tells you to fix it. All you have to do is copy. I missed. question mark zoom equals 1, and then paste it. Sorry, I can't do all this with the mouse. Control copy, and then paste it into the URL. I apparently can't do it with the mouse either. So I want to hit OK, and I want to go up here to my URL. Oh, it's a small screen, sorry. Let's go to the end. Am I at the end? Yes. Control paste, hit enter. And guess what? You start all over. But this time it will let you zoom as far as you want. Let's go back to satellite. So you see, yeah, this looks like a good place right in here. It's all countryside. Let's see, whoops. Okay, here we go. And you can get down to the point of, I think I want to be next to this tree right here. That's where I'm going to check it out. And honestly, this is what I did for this year's eclipse. I scoped out lots of places in Wyoming and Nebraska to figure out where we were going to go. That and the fact that they sold out hotels in Wyoming like last year kind of helped decide the fact. So this one is about a little over 4 minutes long in 2024. If we go back, we'll see that there's going to be another one. I'm going to just kind of skip ahead here. In 2040, there's one in 2033 if you don't mind going to Montana, but in the 2040s, oh, wrong space, wrong set. There we go, 2041 to 2050. We will find the one that's going to occur in 2045. You notice I've already been to these links, right? There it is. Here's our Google map, right through Colorado. Zoom in a little further. There's Alamosa, no totality. There's downtown Denver, no totality. So, you know, you got friends, you got family in Pueblo, whatever. Of course, in 2045, I'm hoping to still be able to travel. You can go, yeah, just go to these places and check them out, and you can see, I'll go park next to this road to see it. More importantly, how long is it going to last? So you click once, and it gives you this information. Duration, 5 minutes, 20 seconds. Whoa. Here in Colorado. Gives you the time that you have to be here UT, do the conversion so you don't miss it. Interestingly though, if you are willing to travel down to Florida at the point of greatest duration, Port Lucie, 6 minutes, 6 seconds. Yeah, start popping those vitamins. You got to make it. So this is a way to find out what eclipses are coming up, where can you go to see them, what are the conditions going to be of the eclipse. You ready to see this year's? Yes. All right, let's take a look at this year's. Just want to make sure you're not bored or something. Here we go. This year, we need to go back. Which decade is this? This is 2011 to 2020. Scroll down. 2017, August 21st. The first day of classes. I've already told my boss I'm going to be sick. What did I just click? I have no idea what I clicked. Let's try this again. No, this. Oh, this is their main page here, so we just have to find their map. They've moved it. Google Map. Let's try this one. Was there? Oh, yeah, but I clicked on the Google Map thing. Oh, okay. Wow, they have changed this since I looked at it last. Sorry. Okay. That is definitely the one I want. We'll go here, and I know I found it from their main site, so let's go there. Somewhere down here. Oh, is there more pizza? Uche, they found out you were still hungry. Okay, now I'm a little ticked off at NASA for hiding my map. Wow. Yes, I think we're back to that. So.
Map, right there.
Wait, whoops.
On the right. On the right.
On the right?
Interactive map, right there.
Really? All right, okay, let's see if it loads up for us here. There it is. Okay, so this year's is going to pass, well, let's back up a little. It'll enter from the Pacific, it'll enter the mainland there in Oregon, pass through Idaho, Wyoming, Nebraska, Missouri, Tennessee, out to South Carolina. The astronomer who wrote the textbook I use for my astronomy class is leading a group in Idaho Falls for this eclipse. Back in, it was December, I think, he sent an email out saying, if you guys want to go, you better book now because I got you a special price, only $500 or $600 a night, minimum 3 nights. They are gouging. And even 3 months ago, maybe, we were trying to book reservations somewhere, and everything along the path of totality was booked. We had to go 2 hours away from the center line to find a hotel. Yeah. So anyway, you decide where you want to go. You think, okay, maybe Wyoming. Maybe we'll go up to, look at that, Casper. Why not? Zoom in. The conditions here at Casper, 2 minutes, 26.3 seconds. Almost 2.5 minutes. That's not bad. I'll bet that place is going to be a madhouse. So you think, well, maybe further down, there's this park. There's a state park right here at this lake, right? 2 minutes, 28 seconds. We're actually going to Alliance, where we have to stay down here in Sterling. Is the only place we can get a reservation. It's about 2 hours. And in this area, it's going to be 2 hours and 30 seconds. Sorry, 2 minutes and 30 seconds. Yeah, my brain is wandering to Alliance already. And the great thing about Alliance, about this area, if you look at the satellite map, is you see all this stuff here? These are called the sand hills. They cover hundreds of square miles, and there's nothing there. There's dirt roads, but lots of wide open space. So I think this might be a great place to go to have lots of space and not worry about the sun being blocked or whatever. Also, the weather forecast that time of year, we've got about a 90% chance of not totally overcast, something like 50% chance of totally clear. I don't know if you can do any better than that. Okay, questions about the NASA Eclipse website? Yes?
Show us Idaho, because that's where I'm thinking of going.
Okay, whoops, sorry. I keep crossing over these little markers I placed. So Idaho, it's going to pass north of that valley where Boise and all those cities are. So eastern Idaho, right over here. Idaho Falls, Rexburg's pretty close. Do you have family or friends there?
No, but
Yeah.
there's a road stop.
Okay. If they take reservations, you may be out of luck.
No, I've called.
Oh, good.
They've been booked 5 years.
There you go.
And Teton, same thing. So it's not.
Yeah. So if you want to go to the 2024 eclipse, we should probably be booking now. Other questions? Anything else? All right. Let's go back to
Yes, how long is that going to last?
Here?
in that Idaho
Cascade.
place? Cascade, Idaho.
Where's Cascade at?
To the left side. Right there.
Right there. 1 minute 59 seconds. That's not bad.
At what time of day?
Okay. So this is Idaho Pacific time or Mountain time? They're Mountain time, right?
Yes.
And so we're going to have to subtract 6. So 10 a.m., 10, 11 a.m. is the start of partial. Start of totality is 11:26 is when totality starts. Yep, in the morning. Yep. This is a solar eclipse. Subtract. Aren't they mountain time? I think Idaho is mountain time. Yeah. Okay, so let's go back to the show already in progress. This is some pictures I took by cutting the lens out of one of these, and I just taped it with electrical tape on the lens of my camera. And I put it on a tripod and I took these pictures. I had a little bit of a telephoto lens, but that's it. And they turned out really good. And there's your annularity. When the moon, the center of the moon, I got as close to the center line as I could, thanks to NASA's website. So what will a total solar eclipse look like? You'll see pictures like this all over the place. This is the sun's corona. You got solar mass ejections just shooting all kinds of material out into space. It will become visible because most of the sunlight's blocked out. The brighter stars will come out. I've heard birds roost. It gets colder, noticeably colder. It's like dusk, basically. I've never experienced it, but I'm looking forward to it. Now, yeah.
Could I ask a question here? I don't understand why
because there's still enough of the sunlight here, and if you think about all around you, there's sunlight coming into our atmosphere and scattering.
So it's still, there's enough coming around it.
Yeah.
Okay.
Yeah. Yeah, the sky looks blue because of scattered sunlight, and there's enough of that scattered light to wash out planets, stars. Yeah.
I'm not sure of the year, and I saw you when you were doing the thing.
The planetarium?
Yeah.
Yeah.
I saw total Antigonish, Nova Scotia, 70 or 72. I think it was 72.
Okay.
And I'm not sure what type of total. There was definitely the corona, because I've got photographs.
Oh, okay. So you were there in Nova Scotia to see it?
Yeah.
Nice.
Went there for it.
Cool.
And-
We can look it up. Maybe afterwards we can look that specific one up.
But the thing is, we were sitting on a kind of a plateau over a cliff over the ocean.
Okay.
And the ocean went totally nuts. The wind went crazy. It went all swirly, almost, it didn't know what to do.
That's cool.
And again, you've got tidal forces that weren't behaving normally.
Well, I don't think tidal forces will be affected, but the winds will blow up waves that go nuts if the winds go crazy.
And it was probably on the high tide side anyway.
Okay. And if you think about nighttime, dusk falls fairly slowly. Maybe this eclipse cooled down the atmosphere quicker so that the winds went more nuts.
And the light went weird. And the other thing too, it took a long time going in from partial.
Yeah, it's about an hour.
And you watch the skylight and the way, and the animals do get weird, and it gets silent.
Yeah.
It's scary
Cool.
too.
Looking forward to it.
That was.
Yeah. So you see pictures like this, but you might ask, because this is taken by a camera, put on a tripod, and it could be the right timed exposure and everything. What will it really look like if I'm just standing there watching? It'll be probably more like that. If you want to get an idea for how big the sun is in the sky, most people think it's a lot bigger than it really is. Hold up one finger at arm's length, look at that one fingernail, and imagine about half of it. About half of one finger is all it takes to cover up the sun. So it's a little thing up in the sky. I'm hoping it's that bright, but we'll see. And don't expect pictures from me. We'll talk about that in a few minutes. Okay, how do we view the eclipse safely? First of all, get something that is safe for looking at the sun. These are for you guys to take. Take one home with you, two if you have a spouse. Make sure you put them on. You can go outside and look at the sun right now if you want to with these. It looks like it's sunny. You won't see much other than a little orange disk. Sometimes there will be sunspots big enough to see by eye, but that's not real common. But this is fine. This is what you need to use as long as any part of the sun is exposed. So throughout the partial phase of the eclipse, you can be watching like this. Now let me give you a warning. When you look at the sun and you decide you're done, don't move the glasses first. Okay. First of all, look down, then move the glasses. Not that I would ever do that myself. Guys talk, you hear things, I've heard it hurts. So make sure you look down before you remove them and put them on before you look up, okay, just for safety's sake. There are, you can go to a place like rainbowsymphony.com and get these. Also, they have wraparound cool solar glasses. They have binoculars you can look at the sun with.
I bought a number 14 welder's shade
Yep.
glass. It's about $4.
Yep.
Airdas.
Yeah, there's another way to do it. You just got to make sure that what you're getting is certified for looking at the sun, or you can't actually damage your eyes. If you don't have those, or you want to try something a little different, you can create a pinhole camera, which basically just means take a sheet of paper, punch a little hole in it, like a needle, and then hold it up. You want a big sheet of paper because you need some shadow around it. Hold it up above another sheet of paper, and you'll see an image of the sun right there. That image right there of the sun is round because the sun is round. It's not round because the hole is round. In fact, look at that. That's a triangular hole. A pinhole camera creates an image of whatever is creating the light that shines through it. So you're seeing an image of the sun there. This works best if you can, first of all, make them far away to make it bigger, and get this area really dark, cover it with a shroud or something. It would work the best. But you don't actually have to even build a pinhole camera. This is a picture of sunlight during a partial eclipse filtering through the leaves of a tree. And all those little spaces that allow sunlight through create images of the partially eclipsed sun. All of those little crescents are partially eclipsed suns. You can do it with kitchen utensils. You see all the crescents? That's the partially eclipsed sun being imaged by all the little holes in it. You can do it with your hands. You see the crescents here, right? Here is a group of people doing it with their hands next to a tree. So these are basically little natural pinhole cameras that you can make. And what makes it as big as it is the distance between the tree and the wall. The longer that distance is, the bigger your image is going to get. Now, as far as taking pictures, if you want to actually get pictures of the eclipse, it takes planning, it takes knowledge, which I don't have. It takes work and timing. And so people who chase eclipses all over the world to see as many as they can, they take great pictures, and you know what? They're going to put them up on the web. And you can go get them later. That's my plan. So my advice is, rather than trying to get your own pictures, just enjoy the experience. That's what I'm really looking forward to, is seeing it, feeling it, hearing, because people go crazy, it gets quiet. I'm looking forward to experiencing it and not trying to photograph the darn thing. Just remember, whatever you do, and here in Alamosa, by the way, it's going to be around 85, 86% partial. 85 or 86% of the sun will be covered. During the eclipse, unless it is total, use the glasses, protect your eyes. Okay? With that,
When it becomes total, what will you see through the glasses?
nothing. When it becomes total, take the glasses off. Thank you. When it becomes total, you take the glasses off and look with your eyes. You're safe at that point. Did you guys know it's Star Wars Day? Yeah. I didn't know that till this morning, and I said, I got to put that in here. May the 4th be with you. Isn't that great? And enjoy the eclipse. Any questions?
I have a dumb question.
I love dumb questions.
Good. So, looking at the eclipse when it's still got some sun exposed, is that harder on your eyes than looking at the sun normally?
No. There is nothing, it's not focusing rays or anything. It's just the surface of the sun is so hot and so bright that it can do damage. And so you just want to avoid it at all times. It is the same as normal. But back in the 70s and 80s, they used to warn kids, do not look at the eclipse, you'll go blind. Blah. They made it out to be a horrible thing. And I read a blog entry or something from an astronomer who was a kid in elementary school when that eclipse happened in the Northwest in '79. And they did not let them go outside. They basically scared them to death. They sat inside and watched on TV. And he is so ticked off now. He is on this campaign to let everybody know it's okay to go out and look at the eclipse. And I credit him for that. Yeah, Tim.
Robert, I'm curious, this tilt angle of the moon, is that fixed? Or does that vary as well?
I don't think that varies nearly as much as things like the semi-major axis and the line of nodes. Those things I think wander a lot more than the inclination of the orbit. I think it would take more of a perturbation to move that. That's my guess. I don't know for sure, but I don't think that one moves as much.
So I have one more question. Yeah. So over at Chimney Rock, that solar marker marks what I thought was a 18.4-year lunar cycle, but this is 18, you said 18.
Saros Cycle is 18 years, 11 1/3 days. There is another one that's similar I'm not familiar with right now.
So it's probably just marking the moon at a particular spot.
So it seems to me the markers that the Native Americans and ancient Native Americans left marked things like the lunar standstill, meaning if you watch where on the horizon the moon rises, over time it changes, and that when it goes as far south as it's going to go and then it turns and comes back, that instant that it's turning around is called standstill. And it's a little complicated. It's not as straightforward as the sun's. Right? During the year, it goes south in our winter, and then it comes back north in our summer, the point that it rises. And so its standstills are very easy to understand. The moons are more complicated, but I think it's something like that they use there, they have there. Okay, thank you all for coming.